Good morning, guys. I'm gonna stream this weekend. Normally, I don't. We started on a simple text game, an RPG. We got pretty far, but there's probably another hour to wrap it up. So I want to wrap it up and then push it up to GitHub. So first off, though, you can see Visual Studio, you can see the code. So this is where we're at so far. This was from Tuesday morning stream. We've got, what do we have so far? I'll try to remember because I'm just sitting down in front of Visual Studio for the first time since Tuesday, but I guess we can go through each one of the files. So we created engine.h. It's simply used to store some helper functions. In this case, we have a roll dice. It takes a min and a max integer value, and we can just represent a random dice roll. So since it's an RPG, it's like Dungeons and Dragons. We definitely are going to use the roll dice method a lot, or we have. Map.h. So we defined a structure called point. Point is simply there to show the player's position on the map. We haven't really done much with the map, though. I mean, the player does move north, south, east, west. There's no bounds to the map, though. Like, he could move to infinity in any direction. And all we really do is we just generate a monster randomly. So as a player moves somewhere on the map, we call this generate monster function, which does like a dice roll, and based on the dice roll, we come up with a monster that he has to battle or run away from. Now that I think of this, we're going to have to go into this function today and fix it because I don't think it has the non-encounter roll handled. And what I mean by that is I think we were trying to have like a dice roll, and if it was like, let's say 1 through 5 out of like a dice roll of 20, if it was 1 through 5, there was no encounter, so the player is safe. But I don't think I'm handling that case, so I think we're gonna have to go into generate monster and have a look. Print player position, that's just simply a helper function that prints out to the console, you know, how far north, east, west, south the player is. Again, unfortunately, right now we're not using the coordinate. I think maybe I will. I don't think I'll do it today because I'm going to keep the stream short and wrap up the game today. But it would be good to handle maybe like a text file that we read when we load the game that has the different levels. And we can have certain things on the map. So as the player moves, he might encounter a stairwell, takes him to another level of the dungeon or whatever. So yeah, so that we want to handle at some point, but not today. Okay, monster.h. Monster.h, just like player.h, this is our non-player character. The monster, just like a player, has a weapon. He's got hit points. He has an accuracy, which allows him to hit the player easier. He's got an armor raider, which allows him to deflect some of the damage if he takes it. And the monster also has a field, a member variable for experience. And that's what the player gets as experience points when he defeats that specific type of monster. We've got a constructor that takes in a string. And based on that string, that's the type of monster we construct. Maybe not the best thing to use a string as kind of your discriminator to see what type of monster you're going to get. It'd probably be better if it was maybe an enumeration or, you know, something a little more concrete than a string where case sensitivity is in play. But it's a simple game, no big deal. We just made it explicit to make sure that there's no casting involved. We pass a string, we get back a monster, we don't get back a string. It's not necessary, but Yeah, sometimes it's just good to have that there. Get hint points returns an integer, a constant method, so it returns back a constant int. It simply wraps this monster hit point member variable. This is just a getter for that. Same with armor, wraps monster armor. Get experience wraps this, and so on. Get weapon. Do damage, I think. Oh, that's when the player hits the monster, and based on the damage the player did, we just pass it into this function and it applies the damage to the monster. Is defeated just checks to see if his hit points are 0 or below. So we've defeated the monster. Perform action taking the player. Can't quite remember what that is. That's the action the monster does towards the player. So the monster will attack the player. We pass in the player pointer, so we get a reference to the player, and we can perform the damage against the player, and also we can see the player's armor rating, so the player can deflect some of that damage. Print stats simply prints out to the console the stats of the monster, like his current hit points, that kind of stuff. So player, looking at player header, it's almost the same as the monster. There's definitely a few more things because the player is, the player is a player. So the player, we define a class. So when we first start the game, we call this function here called generate player. Yeah, I might be able to, let's do this. That's a little easier to read. Okay, so generate player is called right at the beginning of the game. This is where we give our player a name and choose his character class, which is barbarian, mage, rogue, druid. Then we've got heal function. So during battle, we can, I shouldn't say during battle, during our movement phase, we can choose to camp or heal our player. Print stats prints out the stats of the player. Is defeated, just like the monster, we check to see if his hit points are 0 or lower. Assign experience takes in the experience points we're going to assign to that player. We do a level check. So since it's a role-playing game, we definitely use those experience points, and we level him up based on the experience points he gets, and that improves his accuracy and his hit points and all that stuff. Get name just returns back the name we gave our player. Get armor wraps the armor rating. Do damage is the damage applied to the player if he takes a hit. Weapon is pretty straightforward. We just defined a class called weapon, and the weapon has a name and it has a damage dice, so the die roll that weapon does for damage. And then here's our implementation. So our map constructor, so when we initialize the map at game start, we set the player to basically the bottom left coordinate, 0, 0. Get his position returns back the position. The move player function. A lot of these functions, I've incorporated not only the movement, but I've also incorporated how to gather that movement, such as capturing it through the console. Maybe not the best way to do it, but since it's such a simple game, it saves a lot of complexity by just aggregating the logic kind of into one function. And then just whichever direction he chooses to go, we handle. So it's really just a char that the player inputs. So we prompt him which direction you want to go. So if he chooses north, either lower uppercase N. Then we move him up on the Y. If he chooses south, we move him down on the Y. If he chooses east, we move him, across on the X. If he chooses west, we move him back on the X plane. Print his position, just a helper function to print out to the console as you're playing the game where he is. Then generate monster. This is a static function. You can see the static was defined inside of map.h. All we do is you just randomly roll a dice. If the roll is greater than or equal to 5 and less than or equal to 10, the monster is a rat. Else if it's less than 15. So the problem is here is we want the logic to say if the roll is less than 5, no encounter. So the problem here is if it's less than 5, that's fine. The rat won't get created. But then this nested if will get called if the roll is 4, 3, 2, or 1. So we want to actually create... Let's fix this logic because I know we need to do this. This will fix our no encounter. So probably not the best thing to do. We've already initialized a null pointer on the monster variable. But just so I don't have an empty if for now. So if roll is less than 5, then the monster becomes nothing. So we can get rid of this. So now if the roll is less than or equal to 10, so clearly it's not less than 5 because we would have jumped into here. So if it's less than or equal to 10, so in other words 5, 6, 7, 8, 9, or 10. Yeah. We could actually say this is maybe less than or equal to 5. There's no encounter. Right. We'll leave it at that. So the monsters we can generate goblin, scorpion, and finally if it's a roll of 20, this else clause will create a dragon which has, you know, some pretty tough statistics to battle. We can look at the monster since we were just looking at that monster constructor. So passing in a string such as dragon or goblin, we just simply handle those cases. If it's a goblin, his weapon is a sword. That sword does a damage die of 6, which means we randomize the die roll between 1 and 6, and whatever that damage is what's applied to the player. His accuracy is 10. Hit points he's got are 8, armor rating 3, and the experience he gives the player is 40. So we do that, then we finally set those member variables with those values. We print out the stats of the monster so that as we're playing the game we can see what just got generated. Yeah, we'll dive back into here. Perform action. So the monster is going to attack your player name based on a random dice roll. If the roll is greater than the monster accuracy, the monster misses and we return out. Otherwise it was a hit. We look at the damage die and roll to see the damage done. Then we deduct the player's armor rating from that. You always do at least 1 damage, even if that armor rating reduced the damage to 0 or lower. Or we do the full damage. Yeah, and then we apply that damage to the player. And you'll see a lot of cout statements we've just sprinkled in everywhere so that all of this stuff gets printed out. Finally, print stats for the monster. Just prints out who the monster is and what type of ratings he has. Player, same idea. Generate players where we prompt you, the player, to enter in some stuff to build your player. And we go ahead and we build the player up. To heal, we set the current hit points of the player to his maximum hit points so he gets fully healed. Print stats, just like the monster, we print out the stats of the player. Perform action. So the action for a player is a little bit different than the action for a monster. A monster always just attacks. It never retreats because it doesn't make sense. Because he's there just to be, you know, a thug that does damage. If he's got no intelligence in that, if he's getting defeated and he's going to die, there's no self-prevention mechanism built into him, so he's just going to fight to the death. But the player a little bit different. When you're the player, you can attack, or if you're getting your butt kicked, you can retreat. However, retreating, you'll still take a round of damage from the monster. So if you choose to attack, we take the monster. We use the monster ratings to check to see what type of damage you do. If you retreat, you simply retreat. And these Boolean values flag the program whether you're going to retreat from battle or you're continuing on. So just this Boolean flag is used elsewhere. Assign experience. So when you defeat an enemy, we assign some XP. I remember this comment. This comment I was using to kind of visualize the math of how to handle multiple leveling up. For example, if we kill a dragon, the dragon gives us like a couple hundred experience points. And really, 100 experience points is all we need to get to the next level. So this level check handles our experience points to see if we level up. We put it in a while loop because if there's more than one level to level up during the check, we need to loop to see if we still have experience points that could trickle into another level. But that logic I kind of threw in here without testing it properly. So this logic down here, I think we're going to have to drop a breakpoint and debug through that and make sure my logic is sound to handle multiple leveling. So we'll do that. And then just some getters to wrap some member variables. And do damage is just, if we take damage, this is how it's applied. We'll quickly look at weapon. Weapon has nothing. Everything's defined in the header. There's no functions to implement because I think it's just member variables that we expose. Finally, our program. So our main method, our entry point. We generate a new player. So we create an instance of a player. We generate player, which calls the function for you to create your player character. We print out his stats after you've completed creating him. We create a new map. We just set a game over condition. So this is game over is just a condition where if this gets set to true during our game loop, this is our game loop that just runs throughout the game. If the game is over, then the game is over. So we start up by printing the player's position in the dungeon. Then we prompt the player, what do you want to do? Do you want to quit the game? Do you want to view your stats, which shows you the condition you're in? Do you want to camp to heal yourself? And do you want to move around the dungeon? We've got a monster variable, a pointer to a monster. This gets defined down here randomly at generate monster. So if we move the player, and then we do a random dice roll to see what his random encounter might be. If there's no monster, which we just added to code now, we break out of this switch statement and we do it all over again. If we do have a monster, then we go into another loop, which handles this has retreated right here. So this has retreated Boolean variable. We just basically loop, and if the player remember gets prompted to either attack or to retreat right here. If he chooses to attack, we return false out of this function. You can see the Boolean return. If he chooses to retreat, we return true, and then the player will retreat. But the problem is if he tries to retreat, that's fine, but the monster still gets to perform an attack before we check this has retreated on the next iteration of the while loop. So yeah. So if he's retreated, let's say he hasn't, he's just going to fight to the death. We check after the player's action to see if he's defeated the monster. If so, we get the monster's experience, assign it to the player, and then we do our level check to see if he's leveled up based on that experience he just got. Otherwise, we print the monster's stats to the console and see how much damage like what kind of state the monster is in. Then it's the monster's turn. He does an attack on the player, and then we do the same thing. If the player is defeated, then game over is true. You've been defeated. Otherwise, we just print the player's stats so you can see how well you are doing. You may have taken a lot of damage, so you might want to consider retreating. Finally, once that encounter is done, we call delete on that monster because we actually newed up a monster right here. So we want to call delete and free up that memory. And then we break out of the switch statement and we do another iteration of the loop, which prompts the player, do you want to camp, view your stats, quit, or move? And that's all the game does. At some point, like I said earlier, it'd be really nice to take that map and to read, like populate an array that might draw the walls in the map, in the dungeon. We might put some different encounters in the different locations in the dungeon. We might want to have special treasure, special things that when they're encountered, we can handle those in our game loop. And that would make the game a lot better. Since it's a non-graphical game, we're allowed to, or we're able to really focus our effort on making the game mechanics good versus worrying about the graphics and sprites and collisions and all that. Yeah, which we could do. I mean, we built a game on my stream a few weeks ago where we spent the whole week building a two-dimensional game with sprites, collisions, AI, the whole deal. And yeah, it took a lot longer, right? We built this game basically in a morning. We are coming back here to fix some of the issues that are left over. So on that note, let's run the game so we know how the game plays. So we give our champion a name, Todd. And so one thing we didn't build into the game, and we talked about it on Tuesday, was the barbarian's obviously really strong and really good at attack. The mage, however, would have spell casting abilities, and we didn't code that in. We really should. We really should maybe go back into the game, and if you're a mage character type, maybe we prompt the user to, you know, during the attack phase, instead of just attack and retreat, the mage could also attack with his weak weapon, but he could also cast spell. And based on his level, he might have different spells that you can choose from. And yeah, you know, that's something we should definitely put in. And for the druid, he would probably cast spells as well, but his would be more of like, you know, healing himself. I know the druid has, just from my vague Dungeons and Dragons background, like a druid would have like foresty kind of nature spells. So he could like, you know, have like what vines come out and wrap the enemy. So the enemy can't attack you for a couple of rounds and you can just wail on them. So, you know, the druid could do that. And the rogue would have the ability to dodge, but also like we talked about backstabbing, where the rogue would have the ability to do like a really critical damage to the enemy. So those are things we definitely would want to build into the game. Right now, the barbarian is by far the strongest character because all we've got is just brute force attacking right now in the game. So I'll say Todd's a barbarian. We print out the stats, your accuracy, your armor, your hit points. Your current experience is 0. You need 100 to level up. Right now, you're level 1, and you're at this position. So there's no point camping because we don't need to heal. There's no point viewing the stats because it would just repeat what we just saw here. If we want to quit the game, we can quit, but movement is how we encounter enemies. So we got a dice roll, obviously, that gave us a scorpion. We print out the scorpion stats, so his accuracy is 8. So basically what the accuracy is, how I've coded it, is you're going to do a dice roll between 1 and 20. And if the dice roll is your accuracy or lower, you hit. If it's higher, you miss. So yeah, the Scorpion's accuracy is lower than the Barbarian. His armor rating is fairly high. I guess because he has an exoskeleton, makes sense. His HP is, 10, which for just a random monster, I guess is good. And he gives 80 XP when we kill him. And his weapon is pretty good. It's a stinger, so he's going to try to sting. So we could retreat, but we're doing pretty good right now in this encounter, so we'll attack. You attack the Scorpion with your Great Axe. You did 2 damage. So now we print out the Scorpion's condition. You can see his current hit points. He went from 10 to 8. And then the Scorpion attacks, and he misses. So we print out our condition, which is still great. So again, the Scorpion misses, but also so do I. I missed. It missed. We both did 1 damage in this encounter. So we're just going to attack really quick and get it done. So the Scorpion's getting kind of beat up here. So there we go. You attack the Scorpion, you did 4 damage, and we print out the position. We would have done an experience check, but we didn't level up yet, so we didn't print out anything. It may be a good idea for me to change what got printed out here and be a little more verbose and say, like, you've defeated the Scorpion, congratulations. And if you level up, then we'd print out a little bit more. Okay, so that's how we do the encounters. Now we can simply camp, and I camped, and if we view our stats, we're now fully HP'd, so we've recouped everything. But I think let's go to map, and let's collapse some of these functions so we can read it a little better. What I want to do is when we move the player, when we camp, so where's the heal? Actually, it's on the player. So let's look at our heal function. And I think we left the stream off on Tuesday morning to handle random encounters. So what should we do here? How do we handle a random encounter? Let's go, so we found our heal method. Let's go to program where we would call that, right here. So before we heal, we should probably have the possibility of a random encounter occurring. So I'm just trying to think here. When we move the player. I'm thinking I could cut all of this code and push it into a function. Player. Let's try that. We're not going to need to declare monster there anymore if I do that. We'll just declare it up here in our program for now. We can... I don't know what... I don't know what I want to put in here yet, but bear with me. Bear with me. So map generates. There's no breaks involved here, so We can simply return. We need to get that has retreated. We'll declare it right up at the top. We could auto the monster as well. It could be a const, sure. Okay, so we need to pass in player and game over. So first off, let's handle passing in our player pointer. Now, we should return back a true or a false from this function. And this function, or this return value of Boolean, is going to define whether or not the player has been defeated during this attack phase. So we'll return back is game over, which is false here. We'll set it to true here. Break. What are we breaking out of our while loop? We're breaking out of our while loop. You know, we could remove the else clause. That's fine, but we'll leave it. What does perform action return? It returns a Boolean. Oh yeah, that's fine. Okay, anyway, so we delete the monster, and from here we're going to return back the result of is game over. So is game over is going to be false throughout the encounter unless this if statement gets called, which is when the player is defeated. So if this function returns back a true, then we know the game ends. So let's go right here and let's go do attack, and we'll pass in player. And what are we going to do with that? If we also have is game over defined in our main method. Even though it looks like I'm reusing is game over twice, it's actually a different variable here. And this is the controlling of our main game loop. So if our do attack phase returns back true, that means the player's been defeated, the game is over. And what's going to happen is we set that to true, and then the next iteration of this while loop is game over is true. We break out of the loop, we return from the program, and we exit. So the player's been defeated. So why did I move all of that logic into a new method called doAttack? Well, the reason why I did is because we want to also do attack during our camping phase. And I'm going to have our do attack be applied before a heal occurs. So for example, if we try to camp, we may have to fight before the healing takes place. So it's really can be kind of risky. This do attack, I just want to make sure. Yeah, we generate a random monster. So when we camp, if the dice roll is 5 or lower, then there's no monster generated, and our heal will be applied. So I think this is good. Now we handle random encounters when we move, also when we try to camp and heal. And I like the flow. We move first and encounter after. We encounter first and then heal after if we camp. And during our view stats, we're not going to have any encounters because we're just viewing our stats. And if we quit the game, we quit the game. Yeah, I like that. Let's run the game. And just make sure, I'm going to try to just do a bunch of camping and just see if we encounter. So let's camp. Perfect, we had an encounter. I'm going to retreat. I'm going to camp. I'm going to retreat. I'm going to camp. There. And I did a camp and we had no encounter. So yeah, I think that's working. Okay, so another thing we were going to do. We talked about on Tuesday, the way our attack works is the flow is very linear. The player does his action first. Then if the monster is dead, we exit. And then the monster gets a chance to attack. But that's not very fair. I think we talked about including some sort of initiative where a monster may actually get the upper hand on the player and they get the chance to attack first. So we talked about this on Tuesday, and the best way to probably handle this would be for both the monster class and the player class to derive from a base class that has some of the same functions. In that way, we can swap out this to be a monster or this to be a player. It doesn't really matter because they both do the same perform action function. Who does it first is based on some sort of random initiative check. So this will take a little bit of time to figure out how we're going to do it. What we're going to probably want to do is definitely create a new base class. And we can just call it, what would it be? We can call it actor. Because a monster is really an actor in the game, just like a player is an actor in a game. But when you hear the term actor, that makes a good base class because, it's not very specific. It's a very generic thing, an actor. Whereas a player, a monster is more generalized or more specialized, pardon me. So let's go ahead. We'll create a new header file. We're going to call it actor. And I've been pushing the code into a folder called src, so we'll put it down there. Okay, so let's define our class actor. And what do we want to do? So we're going to have some private, maybe protected, but definitely public. We'll figure it out as we go. So what I think I'll do is I'm going to move both monster.h and player.h to a new tab. So we can see what we want to push down out of player and down out of monster into actor. So that actor can become either a player or a monster, but still have the same functionality of a player or monster. Okay. So what can we do? Let's include actor.h, and let's just publicly inherit our actor. Yeah. So now that we've done that, we can start pushing some of this down. To be honest, a lot of this I think could go down. You really want to make sure things are private so they're not accessible to anybody. But I'm going to make it protected. And I think I'm going to push down quite a bit of this stuff. Like, for example, accuracy, armor rating are shared. However, they do have different member variable names, but that's not a problem. We can fix that. So let's move this stuff down. Accuracy, armor rating. Hit points will be shared, but maximum hit points is something only the player has, so we'll leave that. Monster doesn't have a name, he's got a class, but we can share. Yeah, here's class. So we can push class down. And we need to reference our string header. So name can stay in the player. Max hit points can stay in the player. Experience points needed. Now, I don't know what to do with this because monster experiences experience points the monster provides. We'll leave it for now. So hit points. Oh, both have weapons. So we can push weapon down. We'll include that header file. So we'll leave it at that for now on the player. So defeated is shared between the two. So we can push defeated down. We can push print stats down and player action down. So let's remove from the player and remove from the monster. I'll remove these member variables shortly just because they're referenced by a different name. We'll fix that. Get armor, get hit points. Do damage, I think, can be pushed down. Get weapon can be pushed down. See, a lot of this stuff is really quite shared between the two. All of this stuff, I think, we can just push down. Now, we'll fix this in a second. Just look at our player. I don't think the player is going to need to reference monster anymore. And I don't think monster is going to need to forward declare player. Forward declare is a technique used when you couldn't actually include the header file because there would be a circular reference. So for example, if we included player.h inside of monster.h, well, you can clearly see there'd be a problem because we didn't have this commented out, but player.h would reference monster.h, and then you go to monster.h and it would reference player.h. So you can kind of get around this by using a forward declaration where you define that there is a class called player that can be used inside the monster class. The only problem is the compiler doesn't know the structure of that class. So the monster wouldn't know that player contains accuracy and a constructor that takes in, let's say, a string and all these different things. But what you can do to kind of get around that is, as long as you use the player by reference, so a pointer to the player, then at runtime, that pointer is simply just a pointer, which is a 64-bit pointer. And at runtime, you get that pointer back, and what those member variables and properties and functions are kind of moot at that point. Or they're understandable at that point. Didn't really make sense, but it doesn't matter. Okay, so we can get rid of monster. This guy is definitely going to need to reference, include actor. Okay, good. And just like player, cool. Okay, so yeah, we'll hack through this. We'll get it going at some point here. Yeah. Okay, so the player no longer has a perform action because we push that down. Print stats we push down, so that can go away. Generate player is specific to a player though, and so is heal, so we'll leave that in the player class. Assign experience and level check the same. Get name is also specific to a player. but these two can go away because we push those down. Okay. So let's go back to our actor header, and no longer are we going to perform action against a player. We're going to perform it against an actor. So we could say something along the lines of perform action against, whether it's a monster class that goes in or object or a player object. It doesn't matter because they derive from the base class actor, so actor can represent both. Okay, so we're going to have to obviously implement these inside of actor.cpp. And we're also going to have to fix player.cpp and monster.cpp because they're referencing stuff that's been pushed. So let's see, what do we want to do? Maybe we'll just implement our, let's add a CPP file for actor. And it's in src. So let's see if we can use the magical, we can just let Visual Studio generate the skeleton functions for us. And then what I can do is I'll then move the logic out of player and monster into this base class. So unfortunately, we didn't do this from the start when we created the game, but when we created the game Tuesday morning, we started with nothing. I didn't even have a theme to do. It was just like, I've got nothing to cover. Let's just go ahead and make an RPG, because they're pretty simple, right? Everyone knows how an RPG works. And when you do a text-based one, it's pretty easy. Okay, so let's make this simple. Is defeated. I'm going to drag player back, and I'm going to copy a lot of this stuff out of here. So is defeated returns this. We can get rid of that out of the player. Maybe I should actually move monster over here too. And then is defeated can go as well. And monster hit points, you can go. I'm going to just save this. So we're really broken right now. Like right now, you can see red squigglies and red highlights everywhere. But we are going to make it work. Okay, so we did that. We'll perform action. We'll wait. That's a little more complex, so we'll do that one later. Print stats. Print stats. Maybe I won't push that down into the base class because the stats are printed out a little different for the player versus the monster. So, you know what? Let's just go to actor.h and we'll cut that out. And we'll push it back into player.h and monster.h and save. And then let's look at player stats. Print stats. So print stats looks good for the player. It'll be a little more messed up on the monster because I know he used different conventions for properties. But we're going to turf that. We're going to turf monster.weapon. We're going to turf class. So what is class? What did we name it? Character class. Probably not the best name because that infers our player. We'll change that later. So our shared member variable and armor rating. And I actually should be calling the getter called get armor. Instead, I'm directly calling the the fields, the member variable. Probably not the best approach. And since I said that, I'm actually going to get accuracy. Geez, I want this back here now. So accuracy. So let's do a So let's wrap this guy. We'll make it a const. It returns back constant. And we can go ahead and implement this. And then simply return accuracy. There. And now our squiggly should go away now. So we wrap accuracy, get armor. Armor rating. That way we're never accessing the field directly. That way we can't manipulate it. And we should really make these guys completely private. Right now I think they might be protected. Right now they're protected. They should be completely private so that there's no way a derived class like player or monster can affect them. But we simply can get the value of them wrapping them in these publics. Or we could say this is protected, because basically in a derived class, we can change that later. Okay. And we could use the template pattern where if we push that in the base class, we could make this abstract or virtual. So then we override it. Maybe I'll probably do that, but I might be getting ahead of things here. I'll get rid of that since it's unneeded. So get armor, get hit points. Let's actually wrap get class. So let's implement that. Oh, I already had it. Okay, fair enough. So let's look at actor CPP, get class. We just return back character class. And I'm actually going to rename character class to be called, we can't name it class because class is a keyword in C++, right? Class is a class. So we can just call it actor class. It's good as any. Even though we're an actor, it's kind of redundant, but so we can F2 that. Sometimes refactoring is an iterative approach. You know, you refactor, especially when you're doing as much refactoring as I am right now, where you're pushing a lot of stuff into a base class and you break the two derived classes because of it, and you break all the code that references those classes because of it. So yeah. So yeah. So the actor class got renamed. So get experience. Now, I don't know if I want any experience stuff inside of the base class. I may have to, though. Well, you know what? Let's push everything down. So, experience points. And forget you. And so we'll paste the experience points there. Okay. So get hit points. Let's see what we got here. Current hit points. Perfect. This is just named weapon. Perfect. Good. So we've wrapped our simple getters. Easy enough. Let's go back to player and monster to make sure none of those getters still exists. That's okay. That's okay. Print stat. Yeah, that's good. Let's turf that for declaration. Okay. So we no longer need get armor inside of player because we pushed it down to the actor base class, but we do need name. We do need level check still. We do need assign experience. We still need print stats. We still need heal. We still need generate player. Fortunately, not much is broken on our player class. So perform action, however, takes actor. Now, what am I doing here? Now, abstract, we would have to make the class abstract. That's the only issue. Let me undo all this, and I'm going to think about how I want to handle that. Let's start looking at monster. And let's deal with monster. So our monster constructor. Cool. So what did we name this? Actor class. And just weapon. And I think current hit points. And I think we just named this plain old accuracy. Yeah, see, this is the problem. We could go this. Yeah, maybe I shouldn't do that. We'll look at that in a sec. Armor and what did I name that? Experience points. We have a bit of a dilemma here as well, and what that is we get hit points already. We get armor already. We get experience already. We get class already. We get weapon. Print stats, so we want to call our get experience. We want to get weapon and get its name, and we want to get weapon, its damage dice. Yeah, that's all right. That's okay. So perform action. Do damage. Yeah, see, we've got two options here. Like, I may have to either keep all of these as protected because we do need to set some of these values. like pretty much all of these, because when we construct the monster, we need to be able to set the class and the hit points and the weapon and so on. So either I make them private and I add a protected function called set, and then the setter would take in the argument of the value we want to apply. And that's the best approach. Do I care about that? I don't think I do. I don't think I do. And also, we can just make all of these protected. And therefore, because they'll be basically protected, therefore these are all private to anybody other than player and monster. I'm just thinking maybe I should wrap a setter around these as well. Okay, let's do that. So let's do our getters, but let's also do our setters. Void set weapon. And it returns nothing back, but it takes an argument of weapon. So what else are we setting? So void set class and this std string. I could name it class, but what else can we do? We can do, so we set the weapon, we set the class, the hit points. Yeah, okay. So void. And the pattern for setters is always the same. It's really, it accepts the argument that the getter returns, and it returns nothing. Set armor. I've clearly got an issue typing unsigned. And void set good. So I think that is all we need. Clearly, we're going to have to implement these guys. Just going to have a look here at the stream. I'm going for about an hour here. I'm going to take about a 5 or 10 minute break, and I'm going to make myself fresh coffee. And then we will finish up on the base class stuff and see if there's anything I can. And then what we do here now is we can just call the setter, because we don't have access directly to, well, we won't. I think I'll make these guys private now. And we probably broke some stuff by making those private, but since we have the setters, we just call the setters passing in what we would have assigned on the other side of the equal sign anyway. So that's the whole purpose of a setter and a getter, is you just wrap a field so you can't access the field directly. In this case, I don't know if it's it's a good idea to do it regardless, but in our case, we are simply just assigning a value to that field anyway. There's no we're not guarding for anything like, assigning to hit points inside the setter. It would make sense to guard, like, say, hit points can't be less than 0 and can't be greater than 100. If you access the field directly, of course you can't do any of that guarding logic, but yeah. Okay, cool. Well, I'm going to take a quick break and I'll be back as soon as my coffee's done, and we'll finish off this base class stuff, and we will we'll apply it into the game. We'll add the initiative stuff so that when an encounter does occur, we can roll some randomness and see who wins the initiative, who gets the first attack, monster or player. And then we see how we go. I mean, we'll probably check that code into GitHub because I haven't checked this stuff into GitHub yet. And yeah, if we have enough time, what do I want to do? We could either do two things. We could make the map read from some sort of text file, where we define like almost an array of things that we would put in the dungeon in each kind of block of the dungeon. So as we move, could do that. Or we could code in the functionality for the other character classes like rogue, druid, and mage. Maybe we'll do that. Yeah, okay, let's do that. That's nice and easy, and I don't have to think too much to do that. Okay, I'll be right back. I'll be a few more minutes. Okay. So let's see. Where do we leave off? So we push this private, good. All these are protected, good. So do damage. So do damage. I'm just thinking, maybe we just keep that inside of actor. So let's do damage. And we'll turf it out of the player because I think it's the same. I'm positive I've got the same logic. So it's current hit points minus equals damage. We can look at the monster. Same deal. Hit points minus equals. So we can turf that. Let's just make sure we don't have that. We don't have. Okay, good. So do damage is done. Since I'm here, I might as well do the setter on. Let's just do. Well, let's look. So we got damage done. Perform action is definitely different. Let's make that virtual. And let's make sure we've got to do damage on the player. So, or perform action. So what was the signature of that? So we'll override it and we'll implement. And we already had it in here. So really, I can just do that. And it's just simply a matter of doing this, sort of. So let's work through this. So we've got a pointer to actor. So our dot notation in Visual Studio will get changed to a dereferencing of the pointer. So we just want to get class. So we can do that. I guess I could have simply changed it to a dereference. Okay, so with your weapon, so get weapon. And we'll call it again. So let's just see what's going on here. What am I doing? Well, we're getting an actor. I really should make these public because this is inaccessible because it's protected. We're passing in the base. So we will add a, I think all these getters should be public. And that included the get class. So I think we're good. We may push a few more into public. Maybe push some back into protected. We'll see. I'm not too worried about encapsulating and protecting the variables too much. I mean, there's not much damage that can be done. Not that anybody can do damage. I'm just thinking like if somebody comes in and develops the code more, I think we're in a good state regardless. of going overboard with protecting. So we can call our get accuracy now, but it's get accuracy on us, so it's not against the actor. Okay. Get weapon. And now this will be actor, dereference a pointer to get armor. And since we made it public, it'll be accessible. So actor will dereference and get armor, and life is good. And then same deal here. Do damage, however, needs to be public. Yes. I mean, we had the option of maybe defining, friends, but I don't want to do that here. No. Actor. So we're close. We're going to have a squiggly under do damage just due to the fact it is protected. What does this error say? It's not an error, it's just function definitions for do damage not found. I mean unsigned int, but no, that's not it. I don't know. It's like it. I think Visual Studio just needed to catch up on itself. Okay, so yeah, I think our do damage or perform action is pretty good. I think once we get this base classing done, we can now add to here spell and backstab or special attack once we work on our other character classes. Yeah. And I could have changed that to actually monster because that's the actor that is coming in on player. So, okay. So we've got the player handling our perform action. Now let's do the same deal with our monster. So perform action is virtual in the actor class, which means we can override that, and we will. So if we go here, we can bool perform action. Visual Studio is smart enough to pre-populate everything we need. Now all we need to do is define this as actor, and we should be good to go. We can leave this as player. I don't need to name it actor. Player get name. So it fails on our get name. Right. So maybe I need to push get name. It stinks a bit. I really should have a more generic method in actor called get description. And then the monster would override that. And his description would simply be his monster type, which would be like goblin. And then the player would override that to be, well, let's go ahead and do that. So we can say, we'll leave it public because we need that accessible publicly. So we'll call it get, get description. And we'll make this virtual. We'll make it const because we're not changing anything. So we could do that. And we could implement it so it's default if we don't override it. We can just have it return I don't know, what is it, class? What do we got, class? We could have it return actor class, so we'll simply call our getter on class. But we're going to override that in player. So let me just go to the end of this line. My shortcuts on Windows are rusty. My keyboard shortcuts. I'm not on Windows much anymore, so okay, so what am I doing here? So we're returning back std string. I'm including that. What's the problem? Oh, I guess I should scope that properly. 2 colons. And get description, override. Awesome. So let's implement this inside of our CPP. And for the player, his description is simply going to return his name. What do we call it? Do we have a getter for that? We do. So we'll just return get name. Yeah. So now the monster can call get description. And what this will return is if actor was passed in as the monster derived class, get description wouldn't be overridden in the monster header. So it would just use the actor CPP's function call, which simply returns the class. But if player is passed into actor, it'll look at the virtual table, the V table, to see if there's kind of a virtual override. It takes a little bit of memory to create these V tables. So to be honest, inheritance takes a little bit of memory overhead, but you know, that's what you get. I mean, to have the ability to do object-oriented programming like polymorphism and inheritance and encapsulation and all of that good stuff that comes with it, you do have a slight bit of overhead on memory. But if you didn't have that, then you'd just be basically using C. Okay. I think I'm good here. Okay, so we got that. So we'll call our getter on accuracy. And our getter on... I really should just call getter on get description, because that's describing him. And then getter on weapon. Player get armor, looks good. Damage is whatever it is. And the players do damage. Yeah, the do damage we just implement in actor, which just to make sure I'm... Yeah, looks good. Okay, so that is done. Now let's fix up some of these errors before we continue on. So I guess we should just call get description. Weapon. So we need to set experience points. And since it's a function call, it goes in as an argument, not as an assignment. Set hit points. Good. I should have pluraled that, but we'll survive. And class, we set class. And it'll be type. All type is that string, which is the name of the monster. Weapon. So weapon can no longer be set like this. So we want to set So just a bit of cleanup here, nothing too exciting. So this is the problem when you don't architect or design your programs from the get-go to kind of follow what your outcome is going to eventually become. Like, for example, we started this game and we had our own completely separate monster class and our completely separate player class. And then as we started coding and developing the game, we started to find that like a lot of both of those classes had so much commonality that it made sense to push it into a base class, which we're just working on now. And you can see it. It's a bit of effort, right? It's really a bit of effort to do it. And by me making all these changes, you know, I probably could have snuck in a bug or two here that I totally am unaware of right now and will encounter. I mean, it's completely possible. You know, when you do a lot of code changes, even though they're somewhat trivial, just the probability of you introducing problems is fairly high. So, but the good thing is we made these private, so the actor encapsulates completely all of our core functionality. So I think we're somewhat okay here. I just want to go through the monster. But you can see the monster actually shrunk a bit. Like, I mean, there was a lot more code inside of monster that we were able to turf. So get description is virtual. Perform action is virtual. Okay, sorry. Okay, so let's look again at player and let's just kind of work through him. See if we're good here. So we want to set class. That's too much to change. Here's what I'm going to do instead. I can define you know what? Actually, what I was doing was fine. That's fine. I don't want to introduce more variables, even though they're temporary local to this method. I just don't. I'd prefer to repeat the set again and again. That's fine. If I wasn't retrofitting code, then it might be a different story. So a little bit of brain dead work for me to do here, but so be it. Set accuracy, same deal. Okay, so max hit points. We need to set. So we can't do this double assignment all on one line, on one statement. What we can do, however, is we'll set hit points. Yep, set hit point. And I'm going to actually refactor that shortly to be hit points because it just bothers me that I'm have a bit of poor English. So get hit points. So there, I just split that assignment up into 2 lines. I'll copy this, and this guy becomes 8 hit points, 12, 10. Okay, so experience points, we default to 0. We can actually initialize that. Yeah. Then I think we can just turf out this experience points. Okay, so now setting experience needed. This is actually a field inside a player. It's not pushed down into the base. So we can leave this as is. Same with level, but armor rating we've got to set. So we've got a setter for armor. Okay, so then what we'll do here is we'll define the weapon. We could just create a weapon class here, like a variable on the stack, weapon. And so then these all get fixed, but then once we break out of our switch, we do our set weapon to set that weapon onto our base. That saved a bit of code. Me copying and doing kind of the same mess I did with the setters up here. Just not sure how we're doing here. So much code changes that I hope I haven't changed too much. So here we can set our current hit points to be our maximum hit points. I like the functionality of, I don't know if anybody comes from C#. C# has the idea of constants, and it has the idea of read-only for your variables or your fields. And I like to use read-only a lot, where you can actually set, it behaves like a constant, other than you have the ability to set that constant's value in the constructor, for example. And it's kind of nice where you might derive the hit points in the constructor, kind of like what we're doing here, although it's not in the constructor, but we could probably figure out how to set the maximum hit points so that it becomes read-only or a constant, so that it never changes for the life of the game. The problem with this maximum hit points is it's not a constant, but the problem is it behaves like a constant. So, you know, what we could do is we could set, you know, based on our character class, the constants of the max. It doesn't even work anyway, because max hit points grows as we level up. So we'd have to kind of make a different approach in that we would want to be assured that, yeah, forget what I said. Forget it. It doesn't make sense. It makes sense, but it doesn't work in this situation. Okay, so name. Let's use our get description, because we explicitly overrode that method, that virtual method, and it just simply returns name for the player. It's a little cleaner to use, I think, than just calling his name. Get class, get accuracy, get armor, get hit points. Max hit points has to stay. Experience points is on the base, so we'll call get experience. Experience needed is not in the base, so because we're using the wrapping of getters and setters, we really should be wrapping this field. Same with level, but whatever. We don't want to go overboard with things. Just going to move that down on a line here. And get weapon. Good. So our print stats for our player is looking pretty good. I think that'll work. Perform action we already fixed. Description. Let's look at these now. So we need to set. Set doesn't quite work because the setter simply sets. There's no compound assignment in a setter. So what we need to do is we can define int. It's really unsigned int. We'll declare like temp experience is equal to get experience plus the experience we want to add to it. Not as elegant as we would like. I'm going to make that into an auto, just to free up a bit of space. So now temp is an unsigned int, holds our current experience plus the new amount we want to assign to the guy. And then we can do our set experience, temp experience. So our elegant line of code we had earlier had to go away just due to our getter and setter wrapping we added earlier. Visual Studio is telling me to make it a constant. Yeah, absolutely. Makes sense, right? Where you can make things a constant when you're assigning a value to it for the first time. But after it's already been initialized, you can't change the value ever again. Okay. Well, yeah, I guess you could manipulate memory and you could do it. But okay. Okay, sorry. So get experience points. Then we need to, okay, so these become gross lines as well. There's no more compound arithmetic operators. So we're going to have to, I won't do it on one line. I'll do it, or sorry, I won't do it on two lines like I did here. I'll just do it in one big long line. So we'll set the accuracy, which is going to be equal to get accuracy plus the die roll. Whatever this becomes. Not quite as elegant, but it works. And then we do the same idea for armor rating. So set armor is going to be get armor plus, we're getting the current armor plus we're going to add some roll. Right? So this makes sense. We're leveling up. So he has a 50-50 chance of getting an extra point applied to his armor rating and his accuracy and stuff. Okay. And then, okay. So this line of code stays because max hit points is specific to player. But we need to set his hit points. And again, we're going to refactor that to be plural. And I still have a breakpoint right on this line here because I think I need to check this logic out. Okay. How we doing? How we doing? How we doing? So let's go to program. So, okay. So I think I'm just looking for red squigglies. I guess I could look on error list here as well. I don't know if this error list has to be when I build though. There should be an error list when I don't need to build. but it's build and IntelliSense. I really should be seeing some errors in the IntelliSense. Like in program CPP right here. Anyway. Oh, let's, before we move on, I should get these setters done. So, weapon. Before I do that, I'm actually going to run to the washroom. Sorry. Be right back. All right. So, right. So we need to, this dot weapon is equal to the weapon passed in. And we'll just repeat this down. And just then we can handle all our setters. I'll use the dot notation because Visual Studio is cool in that it'll dereference that to a point, or it'll create a pointer dereference for me. It knows this is accessing a pointer. Okay, so is that underscore? The squigglies are throwing me off. Yeah. So this dot, didn't we name it act? Yeah, okay. What did we call it? Hit points. Current hit points is equal to hit points. rating. So I don't really need to use the this keyword here because the field on the object has a different name than the variable I'm assigning to it. But for example, here we'd have a bit of a conflict, right? Like weapon is referencing weapon, weapon is referencing weapon. So, you know, it doesn't know you're trying to reference the weapon field on the actor object. So hence why we use the this keyword. Okay. So I'll just use this anyway here. Experience points, even though they're not named the same. Probably should always use this keyword anyway. Just like in a for loop or an if statement, you should always use the curly braces even if you're only executing one line after it. It just helps not only you understand what's going on when you come back to your code, but if anybody else picks up from where you left off, you don't confuse them. One thing I hate about Visual Studio is I know it's unsigned int by default when you just use the unsigned keyword, but I prefer to actually be explicit. Maybe I can change that in Visual Studio. I haven't used Visual Studio 2017, which is what I'm using here, as much. I've used Visual Studio for like 20 years, but this version I just installed a month ago because most of my development is on a Mac and Linux, Unix. So I use different compilers and different IDEs that run on those platforms because Visual Studio, it does run on Mac now, but it only runs C# and something else on Macintosh. So I couldn't do Visual Studio C++ development on Mac anyway. Anyway, so I've used Visual Studio 2010 and 13, but yeah, I'm kind of new to this one. It's easy. It's no different than the other ones, but there's some nuances that have slightly changed, and I'll just have to get used to it. Okay, so our setters are good. Our getters are good. Perform action. That is our virtual. We can just have it return false. I know it's a bit of a hack. This is really quite kludgy because, you know, I really should make it abstract and make the class abstract so you can't extend actor, and I should have done that from the get-go, but I don't know. It's Saturday. I want to, honestly, I've been, the last 3 days, I haven't been streaming, and I meant to finish this game so I could push it up to GitHub, and just stuff came up. And now I'm spending my Saturday doing this. I just kind of want to get it done. Okay, player performance. Okay, so let's go through our program now. So monster, it may be a const. I don't really care. You know what? I don't like seeing squigglies, so I'll take his advice. Okay. The problem is we are performing action against monster. So is the error because no suitable conversion from monster to actor exists? Well, we could explicitly downcast, but let's see what we can do here. So let's just go. So what does this return? Generate monster. Maybe I should. Actually, I am taking the wrong approach. I'm taking the wrong approach. Let me collapse this mess. And let's look at actor.h. Sorry, it's a map. Now we got to go fix map so that generate monster can return back actor. Let's do that. In that way, we've generalized generate monster in that it returns the base class. That's probably the best approach for us. So now in map CPP, this needs to return back actor. Let's branch this bad boy out, make sure our logic in here isn't too bad. We're returning back a monster, but it can cast into an actor, so we should be okay with that. I'm just going to look at these other functions to make sure I don't have any squigglies. Nope, good. Excuse me. I've defined my structure point inside of my map.h. Is that the best place to do it? Well, I guess if that's the only place you use that struct, it may have been a better approach to make it a class and put it in its own header file. That's the implementation is in there. Really, a point is a vector too. So most game engines have this built in anyway. So if we were building this using like Cocos 2DX, which was the game engine we used a few weeks ago, we would use a vec2, which represents your X and your Y, but it also brings across a lot of helper functions such as like adding vectors together, diffing the vectors. So, you know, vector A minus vector B would use Pythagoras to get you the difference between them. Yeah, so it's kind of cool to use the game engine stuff. But then again, sometimes it's fun to build your own game engine stuff, like your own vector classes, and do the math yourself. Because it's a little bit of dojo for you, right? It's a little bit of training and working those brain muscles to get your geometry going. Like, I'm not super strong in geometry. You know, at university and even in high school, I was mediocre at best. But, you know, you use it by building games, and your geometry gets really pretty good, and your trig too. So, you know, sometimes it's good to build your own vector classes instead of using the game engine stuff, because you can actually do the math. And just by typing it out, it helps you a lot, I think. Like, it's one thing to maybe use a game engine like Cocos 2DX or Cocos 2D, or, you know, whatever you use, SFML or SDL. I won't count because it's more of like a framework. It doesn't include those vector classes. But, you know, what else is there out there? There's like a ton. I guess like Unreal Engine would have its own vector classes for you to use and so on. But it's one thing to look at those vector classes source code and look at the geometry and the math that's going on. And you learn a bit from doing that, but actually you creating your own vector class or your matrix class to look at how to rotate matrices and how to multiply and how to normalize and stuff like that, you know, it kind of helps your brain learn that stuff. Okay, tangent back to focus. Okay, so the monster's good. Kind of jumping around everywhere just due to the fact that perform action. Oh, so generate monster returns back an actor. Yeah, so actor pointer. So we don't need to dereference. Okay. Monster dot is defeated. So is defeated not on the actor? Should be. So what am I missing here? Is inaccessible. Okay, so we just have a protection issue. So we got to move is defeated into public. Okay, so now print stats. So what can we do with print stats? Well, I can upcast, or is it downcast? I always get them mixed up. The monster, or the actor to the monster. But instead, we should use our pattern of that virtual again. So we can actually say virtual void, I think, print stats takes nothing. And we can just simply go with that. And we can click on the implementation of the function. And then in monster, let's override that. So we can simply type out the signature, which is print stats, and just tab, and it'll put the override in for us. So by saving this, we should see the squiggly, I guess, not go away. I would assume so. Maybe I need to add my implementation first. And then we've already got print stats. Forget the const. Forget that. Print stats, it's inaccessible, so I think all I did wrong is it's protected. There we go. So same deal with perform action. Let's move that into something we can directly access. And expression result unused. Oh yeah, because we have this return a true or a false back if we retreat. Okay. Delete monster. Not too sure. Let's just scroll down. So I'm going to try building this. I'm not confident it's going to be successful. There's a lot of code we changed. So we have a warning. Yeah. We have an int being compared to an unsigned int. That's the issue here. Hey, QJS 1008. Thanks for the follow button. I'm not even listening to what's going on, so I can see the chat, but I can't hear if follows ping and stuff. So hopefully I catch you guys. Oh, Donnie, somebody or other. Thanks for the follow, dude. Yeah. Okay. So this is just a warning due to the left-hand side is an int, the right-hand side returns an unsigned int. Whatever. I shouldn't say whatever, but okay, so good old Tad. And we'll make him a barbarian. So this should be the same as when we started the game, but fortunately we pushed everything down to that actor base class. So let's just play the game and hope things work. So we encountered Scorpion. What do we want to do? We want to attack. I did 1 damage, so yeah, he's down to 9. I'll attack. He's down to 8. 1 damage, down to 7. He keeps missing. He did 2 damage on me, and we can see we got the 13 from our max 15. So yeah, things look pretty good. Let's defeat this monster and see if we get the XP assigned okay. He just doesn't want to go away. Okay, great. So we turfed him. So let's view our stats. So we got 80 XP. So from that encounter, that's right, because I'm pretty sure the Scorpion returns 80 XP. So things are pretty good. I think us using object-oriented programming in C++ by pushing the commonality between player and monster down to the actor base class, using virtual functions and overriding them, it worked for us. But the reason why we really did that is to allow us to include some initiative. So let's figure out how to do initiative. I need to think about it a little bit. It'll be in our program .cpp, which is where our main method is, where our entry point is in our game loop. So right inside of this inner while loop, we need to calculate initiative. Now, do we want to calculate initiative on each turn? If we want to calculate initiative at the beginning of the encounter, we would do it right here outside the while loop. And then we can assign, we can say who the attacker is and the attackee, let's say. Do we want to do it at the beginning of the encounter or on each encounter? Well, let's make it easy. Let's do it here. So how do I want to do it? I don't know. I mean, well, let's do this. Let's not get too chintzy on this. Let's push it into our base class. Unsigned. Initiative. And I might as well initialize that. I should have really initialized all of these, but whatever. So we want to do a setter for that. The nice thing about C# is you can have a property which automatically has the getter and setter inside of it, instead of me having to create two functions, a set function and a get function for initiative. Initiative. And I'm going to just copy this. Then all I need to do is just change this to initiative. Now let's implement that inside of actor. What was that saying? Of course, generate that. So this gets, so we return initiative. I guess I should practice what I preach. Remember how I talked about we should be explicit and use our this? We could do that. Because I haven't done it above, I won't do it though. Do as I say, don't do as I do. So we've got our get. Let's implement our set to set. I have to use the this keyword here though, right? Because the argument coming in is named the same as the field we are setting. So we somehow need to differentiate explicitly who is who. Maybe a const. It could be, sure, whatever. Okay, so we've got initiative set. Now, when we generate our player and we generate our monster, we need to set initiative. So we'll create unsigned int, and we'll initialize that. If you don't put in a value for your initializing of your variable, it'll default to the default value. In this case, it'll be 0u. So I could explicitly put it in like I did earlier, I think on actor.h. Since I didn't elsewhere, I won't. Okay, so let's give this guy an initiative. So what should the rats be? How we'll do it is, what's the best way to do it? Because the initiative should be applied. Okay, I think I know how we'll do it. So we'll say the rat is, he's pretty stealthy because he's a rat, right? And he's small. So he should have a pretty high initiative. Let's say 16, and we'll put the suffix to say unsigned. So we'll say 16. A goblin. Goblins are pretty sneaky, right? So we'll say what, 12? Scorpions are pretty stupid, and they're pretty big, and they probably smell. So we'll say 8. And a dragon. Well, the dragon actually should be fairly high because the dragons are intelligent. They may not be stealthy, but they're not stupid. You know, they probably got good smell and eyesight. I'm just thinking, like, if they encountered, what's the likelihood they would be surprised or, yeah. So I'll say 10 because he's big and lumbery. He shouldn't be as good as a rat or even a goblin, let's say. So then we finally need to set that to our base. There we go. Okay, so we're done with the initiative for the monster. Now we got to deal with the player's initiative. Oh, we should print it out too. Do we want to print out the initiative for... Well, might as well. I'll just copy accuracy. And we'll just say initiative is get. And yeah, so I think the monster is done. We'll print out the initiative for our player. Get initiative. Right? And all these are coming from the base class actor. Okay, so now we're printing it. We just need to set it, which we do here when we generate player. So what would the initiative be for a barbarian? To be honest, the barbarian shouldn't have a very high armor rating because don't they run around in loincloths and stuff? To be honest, his armor rating should be pretty low. If a mage is 2, I guess the barbarian should be higher than a mage, but I'm going to leave him at 2 because he's really unbalanced right now. He's completely dominant. That'll change as we code in the other classes though. So his initiative, what would a barbarian be? I mean, like, a barbarian has those not spidey senses, but a barbarian's kind of like he knows kind of the, I don't know, what am I trying to get at? A barbarian is like not quite like a hunter or ranger where he's good at tracking, and you know, does that really affect initiative? I don't know. I mean, like, I play Dungeons and Dragons now and again, but it's not like I'm the super geek, right? Like when I play with the super geeks, they totally, oh no, you don't want to do that. No, you don't do that. And I'm just like, oh, okay, I'll take your word for it. So what do I know? Initiative for a barbarian. Would he be the same as a goblin, let's say? I don't know. Yeah, he shouldn't be as bad as a scorpion. Should he be as good as a goblin? I don't know. I'll say he's 11. We'll put U in. You don't have to put in U. It's just the suffix for unsigned. If you set warnings to all on the compiler, like the switch W all, we would get a warning about an int going into unsigned int. Okay. Yeah, I'm okay with that. I mean, like, who cares, right? Like, we're going to tweak. We just want to get generally the right values for these characters, and then we tweak them to make the game challenging. So what's the initiative for a mage? I don't know if he should be as good as a barbarian. A druid, I don't think he's very good either. I don't know. But a rogue should be really high. I think a rogue should be like on par with that rat. Sure. Why not? So we set that and we're printing it. So yeah, I think our initiative is done. The only thing now is we need to handle how the initiative works. So so we'll do our initiative check. So how should we do that? We should take, I think I did this logic somewhere else, where we do the delta between the monster and the player's initiative, and that difference is kind of like a positive for the guy who's got more initiative and negative for the other guy. We do a die roll, and okay, let's just see. So let's say we take int so just lowercase d for delta initiative. I don't know. That's gonna work for now. So we've got the player, we've got the monster. So we could go player get initiative minus we named it monster. It'll dereference that pointer for us. And I'll push this onto a new line here. So it's, I don't like how it doesn't automatically tab in for you. I don't find it readable at all to have it on one line. Anyway, okay, so that's our delta in initiative, our difference between our player and our monster initiative. So we want to do a die roll. Just thinking how I want to do this. Just bear with me. It's easy when I'm coding and it's stuff that is rote, like rote memory. I can just code and I can talk and stream. But now I got to think about the logic of like, well, how am I going to use this delta initiative to define initiative? So I may cheat because I know I've used that concept somewhere. Where did I do that? I thought I did that. You know what? I'll figure it out. I don't want to do that. So delta initiative. So let's assume. So let's just work through this. Let's assume the player's initiative is 11, and the monster is 16. So we're going to get back -5, right? So we don't have an unsigned. We have an int. We could say it's a short. It doesn't matter. We're not too worried about conserving being overly performant. Okay. So the monster has a better chance at winning initiative. So what do I want to do? What do I want to do? Well, what I could do, okay, so then let's say we roll die, and since we use our 20-sided dice mostly, we'll, did I already declare roll as a variable? I thought I did. Okay, good. So I'll just use auto roll. I could use auto here as well. Unsigned and unsigned, not what I want. Okay, so auto roll. Okay, so I'm going to put that comment there. So now let's assume the roll is a 15. And we minus our delta initiative. And that gives us 10. No, sorry, minusing. let's say we add. Let's just work through this. So adding -5 to 15, so we get 10. So now the initiative is split down the middle. So what we can do is we can say if less than 10, I'm just doing pseudocode. If less than 10, monster wins init. It's still a little unbalanced, and that's because I guess we're using even numbers, so it's hard to find kind of an exact middle point. But we don't mind unbalancing it just a touch in favor of the player. Now, if greater than or equal to 10, and this equal sign makes it a slightly unbalanced in favor of the player because it's not completely equal. Okay, we could do something like this. So let's try this. I think this will work. I think this will work. What I'm going to do is, so let's minus the delta initiative, and we're going to store this as an int because it could potentially be on a negative scale. So now let's do our logic. So if roll is less than 10, oh, a lot. Okay. Else, because there's only one alternative path, so we don't need to do a second if. Platter wins. Okay, so I'm going to copy out my pseudo logic. Cut out. What does it want? Const? Yeah, it wants const, and again, const. Makes sense. So, okay, so now what do we need to do? So we need to make the monster, the monster, the player, the player. So really what we should do is we could say player and monster. Now, let's try this. So what we want to do is we won't directly use player and monster anymore. What we will do is we'll create actor, pointer, and attacker, and actor, and I'll make that a null PTR in a sec. Attacker, defender. Yeah. Okay. Okay. So basically, if we're in this case, the attacker becomes the monster and the defender becomes the player. And if we go on the else, it's the exact opposite. I mean, even still, what we could do is forget the else, and we could directly assign the player as the attacker, and we could directly assign the monster as the defender, and that'll stay this way. Yeah, I could use auto for sure. I don't want to, but I could. And this do attack could actually be actor. I should almost change that, but whatever. Right. So yeah. So if the attacker is always going to be the player unless our initiative check tells us otherwise, and we'll just swap it. So then there's no need for that else clause. Platter. Okay. Why not? That'll work. Okay. So now we have to do inside of this while loop, which is our attack loop, right? If a retreat occurs, then we break out of the loop. But inside of here is where we're going to use attacker and defender. So this is the attacker perform action. And we wouldn't have been able to do any of what we're doing now if we didn't use that actor base class. So this is polymorphism in action, right? Where a player can become an actor or a monster can become an actor. Okay, so attacker, perform action against defender. Defender. Basically, anywhere we see monster, he becomes defender. Defender. Attacker. Oh, yeah. Assign experience. Well, we're going to leave that and we're going to let it break, and then that'll tell me to go and fix it in the base implementation. And we'll make it virtual again because the only person who really uses the experience assignment is the player. You'll see what I mean shortly. And we'll have to fix that there. And it's just saying here the else is redundant, because we do a break statement, so we break out of the loop. So anything that occurs after it is irrelevant. But I'll leave the else because it's more readable. Defender's turn. Oh, I better fix that. Anywhere where we see monsters, defender, and player is attacker. Simple as that. Within this loop. Defender, attacker. Attacker does not have get name. He should actually. I thought I had get name. Okay, that's fine. Player is attacker. And what can we delete? Well, we can delete our monster. We'll delete our monster. And we can just set attacker to null PTR and defender to null PTR. We definitely don't want to delete our player because that would be, so if we did the delete on defender or attacker, we would be deleting because we don't know who the attacker is. The attacker could be the player, the monster, we don't know. So we have to explicitly delete the nude up monster, which happens right here. Wants to be const. Yeah. Sometimes the squigglies are a bit overkill. The hints it tries to give me. Okay, so now let's go into actor and allow assign experience and level check. So we will make, and we got to make them public, but virtual as well. All right, so assign experience. I don't think it returns anything. It just takes in an unsigned integer constant. Okay. So const unsigned int Okay, so that's virtual. Life is good. Let's just work on this guy for now. So all this does is we can just look at player's implementation. Where's our player? And just move this logic in here. Oh, no, sorry. No, forget what I just said. We are going to override this method and we're going to leave it inside of here to do nothing. That way, if monster happens to be the guy getting the experience, so be it, but it doesn't get applied to him because this function does nothing. But we want to override it on the player. So if the player is getting the assigned experience, you'll see, we'll debug through it and we can see how this works. Inheritance and polymorphism can get kind of tricky. If you can't visualize the concept in a V table, you may want to just Google V table or virtual table and maybe get some sort of visual examples from Google of how polymorphism works and the virtual table works. Okay, but we'll debug through it and try to help explain it. Okay, set experience. Okay, sorry. So we made that virtual inside of actor. We did implement it, but it does nothing. Player.h. So now we want to override that in here. So let me see if override will just, yeah, I can't just do it. So let's go void. What did I name it? Assign. And you can see Visual Studio. If you can kind of squint, you can see the little V on top of the method icon on the very far left means it's a virtual method or function. I kind of say sometimes some languages refer to functions as methods. Some refer to methods as functions. If you're a C, C++ guy, you should say function. If you're a C# guy or most modern languages, you tend to say method. But it's synonymous. I mean, like if you say one over the other, people know what you mean. Okay. Override. Perfect. So now let's implement our overridden. And it just conflicts. So it should be here. So it's done. Should be. Has already been defined or declared. Oh, right here. I see what the error. Okay. So now we need to do our level check, I think was the next error we're trying to correct. So now we need to go to actor H and create level check. It's a void that takes void. We'll just do it here as well. Level check. Hey, Rusta Mehind. Thanks for the follow. Okay. Okay, so what am I doing here? Level check takes nothing. It's virtual, which means we can override it. Definitely the monster is not going to override assign or level check because he doesn't get experience. He just dies. He's there to become the guy to give us experience, so we don't care about him. But you can see I'm implementing it inside a player CPP. So level check is all done for us. We just need to override it in... we should also create an empty definition inside of actor so that when monster does call this level check, it calls into this function. You can see it, but there's nothing going on. So it doesn't break our logic in our program, in our attack loop. Hey, Volatile Majesty. How's it going? Thanks for the follow, dude. That's great. Okay, sorry, I was off track. Okay, so actor's done. We just need to go player, header, and put our... I really should make some space. You know what? I should just unpin that, and then we can see our code a little better. Okay, so player needs to override level check. And level check was void. Why am I not seeing what I want to see? Where's actor.h? Control Shift N. Actor.h. Virtual void level check. What am I missing? Oh, yeah, okay. So the same error I had before. We already had the function on the player, but we're not overriding it from the base class. So we got to remove that. See, this is the problem with retrofitting your code and making these drastic changes to the structure of your classes. It kind of throws you off. And some of it you don't get an error about. So you have to deal with the hard way, which is typically a runtime error. Or even more insidious, it's one of those insidious bugs that it's not a runtime error. It's just, you get garbage values somewhere and you got to derive what happened, and you got to work backwards. But we're good. We know what we're doing here. Okay, so level check is good and assign experience. So yeah, that's great. So now what's going to happen is the attacker could be the player, or attacker could be our monster, right? We don't know which. Depends on our initiative role. But because level check is implemented, because level check and assign experience are implemented on our base class, which is actor, if the monster has assign experience applied and level check applied, it'll just go into here and it'll do nothing, right? But since player overrid the level check and assign experience, then player class, the V table will look, oh, you're really a player, not an actor class. Oh, you've overridden this method, so we're going to come in here, and then we'll come in here to do level check for the player. So we should be good. I think all the logic I've been spewing out is going to be good. Okay, so finally now attacker get name. So we just need to push that to the base class. I thought I did. We called it get description. Oh, yeah, that's all we need. Get name is the same as get description. So that's all we need. Now actually we can turf get name out of player, because it was only in player. And that might break something because it might be referenced elsewhere. We'll see. Let's just Control Shift B, see how our build goes, see if we got some errors. So we've got one error. Yeah, get name was referenced, so I didn't remove it. Okay. Well, let's just do this. I'll just directly access our name field. So forget the get name. We'll just go name, return name, which returns the value stored in our private string field name. So, okay, Control Shift B. And if you guys are into C++ and want to grab this code and change the game, it'll be on GitHub shortly. And my GitHub link is on my Twitch homepage or about page. You can just follow the link there to get to all the source code we've done on any of our streams. Okay, so the build worked. I think the game is kind of good. I hope the initiative works. I think so. You know, we can drop a breakpoint in here and just see the flow. So good old Todd can be a barbarian. So we can see now initiative is being applied. That's great. So let's move and try to get an encounter. So no encounter. Let's try it again. Cool. So player, his initiative, whatever that might be, it's great. Let's F10 works. Good. Initiative is 1. So therefore the player has a slightly higher initiative than the monster's initiative. We are attacking a dragon who has initiative of 10, and we know our initiative was 11 because I think the barbarian I set to 11. So this is good. We got a slightly better chance of becoming the attacker than becoming the defender. But let's do our die roll and we'll find out. Our die roll minus our initiative, which is 1, which still gives us even more of an advantage. So our roll is 12. So unfortunately, the roll was 13, and we deducted 1 from that 13 to give us 12. So unfortunately, oh, yeah, that's good. No, sorry. So our logic, I think, is sound. The roll gives us the advantage. Yeah, that's good. Is that right? Is that right? No. That isn't right. If we deduct, if we have a higher initiative and we're dropping the roll lower, we're giving the monster a better chance. Really how it should work is it should be, where the heck are we? It should be less than or equal to. And we really should do this, where the monster is the attacker, but the player can be if the roll is 10 or less. Yeah. Or I could kind of invert all this and just make it like adding and player whatever. 6 1/2. So let's restart the game. Just make sure. Okay, so let's move. Before we do that, we'll just drop a breakpoint. Just make sure things are working as expected. Okay, so let's move north. So the monster is the attacker. The defender is the player. The roll is, oh, wow. So clearly the monster is like a rat, I would say, because he has that super high initiative. And the roll would have been such a high dice roll. Yeah. We added 5 to the dice roll. There's no way we're getting the initiative there. The roll was just too good. So unfortunately, the monster will still be the attacker, but it's okay because it's just a rat. We'll squash it. So now we go into, this is false, right? We haven't retreated, so we're going to go into our loop. And then we perform the action, and the attacker is the rat, the monster. So if we look, hopefully you can kind of see this little context menu pop up, context window. It tells us our class is actually a monster class. You can see the virtual pointer on the V table points to a monster pointer. So you can see our pointer to the monster. So, and you can see all of the fields that are set. It's a rat. The hit points are 4. Initiative, you know. So good. So we know the attacker is a monster. And we also want to keep playing until we, as the player, become the attacker. So we can test both edge cases of who wins the initiative and make sure there's no bugs in it. So perform action. So what we could do is we could drop the breakpoint in here, and we should come straight to here. And we do. The monster is attacking the player, get description, which will be the player's name, which is Todd. So now we should see the monster attacks Todd. And then we do a dice roll. It's 5. Is it greater than his accuracy? No. So he definitely hits us. His weapon damage die is like D4, I think. So it's going to be between 1 and 4 damage. It's 2. Our armor rating, I think, was 2. So the damage is 0. But if it's less than or equal to 0, we default it to 1. So you always have to do at least 1 damage. You can't deflect everything. So 1 damage will be applied. The monster did 1 damage. And we apply that to our player, which is Todd. Perfect. My F11 doesn't work. My Mac keyboard doesn't seem to work completely with my Windows boot camp. I should have stepped into player, right? Or is do damage on actor? I think it's just on actor because it's the same. Right, here we go. So it's right here. So damage of 1 applied to our 15. We should have 14 hit points. Yeah, it looks good. And it returns false. Yeah, because the monster never retreats. He always returns false from his perform action. So cool. So no retreat. I don't need that breakpoint on there anymore. Oh, did I take it off? I guess I did. Cool. Okay, so defender is defeated. That should return false because our player still has hit points. We print out our player's stats because he's the defender. So if we look on here, we can see, print stats. That was interesting. It's like, yeah, interesting. So we have a little bit of an issue here where our print stats isn't overriding. It's like it's calling this and doing nothing. But player does override. Aha! Our print stats is missing the override keyword. So in other words, it calls the base implementation, which is nothing. So if we add the override keyword in here, I think that's all we should need to do. And that should fix it. So we've got a bug, but not a big deal. See, these are just simple little things that we overlooked. So now the player is going to perform his action. And this action is going to freeze the game execution because it's prompting us to enter in something into the console, whether we want to A or attack or R retreat. So I'm going to F10 over this. Oh, so I made a change. Let's just stop the game. We better make, we just don't have a virtual on here. Print stats. Yeah, we do have virtual. Void. The member declarer does not override the base class's member. Oh, because this const. Yeah, the const. Yeah, don't worry about the const. It's like the IDE kind of gives you some hints that it recommends you put in. Doesn't mean you need to. I'm too lazy. I don't want to add const to things. Okay, so now next time we do this, we should be calling our print stats. We just have to drop consts and we're good. So I took it off there. Okay, good. Yeah, I'm happy with that. Now let's look at our monster header. And we'll change his to override as well. Oh, we already did. We just had 2 declared. Okay, so where's monster CPP? Print stats. There we go. I think we're good. So I fixed that error. Now let's rerun the game. Okay. So I'm going to drop a breakpoint at the last place we were at. Okay, so we're in an encounter with Goblin. The defender is me, so again we are unfortunately the defender and the Goblin is the attacker. But that's good. Now we can test our print stats. So we shouldn't be defeated. We go into print stats. This time we have overridden print stats, so we'll call our own implementation of print stats. So if I drop a breakpoint here, we should be on there next. And we are. So we know we're printing our stats, so I will not step through that. I'm going to drop breakpoint down here though and run to that line. And just to verify, our stats should be out. So it printed our stats. So yeah, our fix is in place. Defender now. So Todd is going to attack Goblin. Like I said before, in this case, it's going to freeze execution because it's going to prompt us to attack or retreat. So it didn't seem to. So maybe we have another bug. Well, good thing we're testing this out nice and slow. Collapse some of this stuff. So perform action const. Perform action const override. So we should have. Interesting. It's virtual. Well, what am I doing? Where am I in execution? I am frozen in execution. Yeah, we're frozen on execution. It just didn't print to the console. Do you want to attack or retreat? Interesting. It shouldn't have done that. There's clearly an issue. But let's just see if A gets handled. If I put a breakpoint down here. No, there's something weird going on. Okay. So let's look at what's going on. Da, 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 da. So this is where it went weird. Oh, and also, before I continue, I should actually copy this. We want to set the return value perform action. If you recall, perform action when it was done by the monster always returns false because he never retreats. But we don't know if the attacker is the player or the defender is the player. So we got to capture and store that in our variable that we use in our while loop to see whether or not the player's retreated. So that needs to be applied on this perform action. Now that didn't fix the issue of what occurred. It's just, yeah, interesting. Okay, so let's just rerun the game. And I don't know why I keep putting in Todd. Okay, so we're just going to try to get an encounter. Good. The attacker, let's hope it's a monster. Awesome. We can see and reproduce the same behavior. So the monster didn't attack. Did 1 damage. The defender isn't defeated, but we print his stats. and we see Todd's stats. Now this is where it got weird, and we should have went into perform action. I'm going to drop breakpoint inside of the base implementation of perform action just to see if it went in there instead. Because I'm a little bit lost here. Why would it do that? No, we go in here. We see out. It gets borked on the see out. Why is it getting borked on the see out? Weird. We're in here, but what the frick? I wonder if there's a weird issue because it's a virtual overridden method. I mean, it could be because it was working perfect before. Why when I do a see out? No, that can't be it. Very strange. So, okay, it worked. It captured the input. Something's hokey. I'm at a bit of a loss. I might have to Google this one. And I may do it later. My stomach is growling. I've got the hiccups because I've been drinking nothing but acidic coffee. And yeah, this is so strange though. So see out. Let's see if that see out worked. It's like it's not see outing anything. Why would that be? I wonder if it's because I aliased with it using directly these, but the base class doesn't. Like I've never really used stream in a base class. Like, okay, I don't know. Well, let's see if that is the case. But let's see how far we get. You know, we're not seeing the output to the console, but so be it. The logic is flowing. So has retreated is false because we attacked. Is the goblin dead? No. And we print the goblin stats. And the see out though is working. Oh. The see out is like it just died. It was working up until we printed the defender's stats. Oh, this is a very strange thing. Very strange. And I mean, it wasn't the aliasing, because like, I mean, I'm aliasing with the usings. Shoot. Did we see your weapon is, like, did we print out the whole thing? Yeah. What the frickin' fricker? What's going on? So let's continue. And right, so we don't roll for initiative on every turn, which we could actually change, but we clearly have our bigger problems just getting stuff to print to the console now. So the attacker, a defeat. Let's just see if anything's getting printed. Nothing. How could the input be? Oh, that second B input. It was just, it was stuck in the buffer. Like I typed A and B. Oh my goodness. Yeah. And I handle the default case. Oh, I don't handle the default case. Okay. So print stats. Now we prompt the player for input, and we're frozen in execution. We'll attack. So our input is A. We're doing okay. It's just, it's not printing to the console. What the heck? Do I have to flush it? Like, am I missing something? Maybe. I don't do a whole lot of see out stuff, so maybe I'm missing something. We'll figure it out. Not a big deal, but it's just bizarre. I'm going to kill these breakpoints and just run it through. And clearly it's prompting us. I just want to get out of the attack phase. And I may be out of the attack phase. I may be expecting us to move now, because that's a lot of attacks. Wow. So let's go ahead and camp. Didn't see any console out. Let's go ahead and move. So the program handles the move. Let's just see if it goes into the... let's just drop a breakpoint here on the expression to capture what the expression is. See if an M comes through. Oh, we're not even... oh, I just didn't hit enter, I guess. So yeah, like things are working great, except the C-outs are borked. So I wonder if I need to flush the C-out buffer. How to flush C-out buffer. The problem is that you're sending null to cout on the last iteration of the while loop, which leads to UB. What is UB? And your case is jamming cout. Check for null before you. It could be, you know what it could have been was I had a, did I have a default case? We'll figure it out. We're on the right track. We know it's not necessarily flushing the buffer, but I kind of like this guy's answer. It sounds like we're passing null into cout, or we're passing something dead into cout, and it's messing with that buffer or that that stream object. Now, do I want to tackle it now, or do I want to eat? I might actually go eat, because this could take a bit of time. Okay, but let's at least pinpoint where it's going on. So we know what's happening when we print the stats of our first attack phase. So it's in our attack loop, which is here. And it's occurring right here is where it's getting borked by the looks of it. It could also be on the player's perform action. But let's look at the player's print stats. So it seems okay to me. Like, Todd's condition, class barbarian, initiative, all of this stuff looks good. Your weapon is weapon name and damage die, which is D8. And L. Seems okay. It could be then happening in the next thing after we print out the stats for the player was the player's perform action gets called. So we go back to player. But
Yeah, this is where it's straight up borked. We don't even get the option of attack retreat. Would it be this endl? I mean, I could explicitly put in a new line instead of endl. I don't think it would be that, but let's just see. Let's just see. You know, it's just a shot in the dark. I mean, sometimes when you get into debugging things you've never really encountered before, you do stupid things like I just did. Let's see. So we want to so I'm quickly going to short circuit so we don't the attacker doesn't become the player. We can turf that out later. So we're always doing the same behavior where the monster and then the player. So that's where our bug seems to be. So move north. Move north. Oh, I'm attacking. Okay. So things are working. Things are working. Now it's working. Could it have been that endl? I don't think so. I'm going to undo that and we'll test it again. So we've defeated the monster. We probably should change our text description saying like, congratulations, you killed him. Okay, so let's leave this goofy little hack to make sure we're always the defender. But let's look at... Let's see if those were the culprits. I don't know how that would be, though. I don't know how that would be. Okay, so let's try again. Okay, so move north. Okay, no, Jesus, working, right? Weird. I don't know how to explain that. I haven't changed anything. I'm a little nervous about that. I don't like it when something corrects itself like that. You know, could have been with debugging in the console and it could be. Okay, well, it seems to be working. So we got the initiative down. What do we want to do? Let's just go back to the program. So we loop through. If the defender is defeated, we actually need to actually duplicate some code here. We actually need to duplicate some code, and I don't like doing this. But for now, it will work. This duplication of copying and pasting will serve a purpose. And here's why I just did that. Is we don't know if the defender is the monster or the player. So if the defender is defeated, the defender's experience points is given to the attacker. Now, attacker could very well be the monster. It could very well be the defender. So we almost have to repeat the same chunk of logic whether the attacker or the defender is defeated. That's great. But we need to know if the player is defeated. We could do a check. Is the attacker the player? Or even simpler is let's do this. Let me X that. Let me cut that out. And I'm kind of mixing up these free functions instead of having member functions. By putting this function on its own up at the top of the main method, it's a free function in that it doesn't belong to a class. It doesn't belong to the player. It doesn't belong to the monster. It doesn't belong to the actor. It's not a good approach. But we can refactor this out later. What I'm going to do is just void check player defeats. And we'll pass in the actual player instance. Don't worry about actor. And we will is defeated. We're going to actually change this to return a Boolean. I want to return true. We'll call it is player defeat. Ed. Player. You've been defeated by, oh, we actually have to pass in the monster. Now this is a little bit gross, but it'll work for now. Because we need to say you've been defeated by monster's name, rest in peace player's name, and return true. Returning true is a bad thing. It means we've been defeated. Otherwise, this if statement never executes and we return false. Okay. Okay. I'm going to copy this. It's getting a little bit gross. And now defender is defeated. We don't know if the defender is the player or not. If player is defeated, passing in player. Fortunately, we still hold reference to player. We still hold reference to monster. Right? We didn't set it to null pointer or delete it at this point, nor did we do that to the player. Actually, we never delete the player. We probably should release his memory when we exit. But anyway, so monster player. Monster, unfortunately, is of type actor, so we'd have to upcast him. But we can just say actor. Okay, so right. So if this if statement returns true, then the player's been defeated. And what we want to do is we want to set the game over variable. I guess I cut that out. Is game over to true. Because what that means is if we break out of this while loop. So as soon as this break is encountered, we leave our attack loop and we're about to evaluate even a more outer loop. Oh, we are inside a function. I forgot we pushed this in. So just simply returning true will actually break us out of this function and return true, which is game over. Oh, we do. Sorry. Sorry. My logic was right. We break out of the loop. We break out of this loop. We've set game over to true. We delete the monster. We set those to null PTR. That's fine. whatever. And we return back is game over, which we set to true, which will go back into the calling code and say, the player's been defeated. Unfortunately, you're done. Unfortunately, though, I have to duplicate this code. And we really need to do a refactor here soon to kind of clean up the bit of the code smell of code duplication. But we need to check when the attacker is defeated, well, is that the player? And the same logic holds true. Okay. So that said, move, do attack, do attack. Yeah, sorry guys. I know that the logic here is getting a little bit gross, but we'll refactor it. That way now we can check to see if the player is defeated. Yeah. Okay. So, let's play. Barbarian, move north, move north. So Todd's fighting a dragon. Awesome. The monster attacks Todd. The dragon misses. What do we want to do? So clearly, again, we're the defender. I better take out that little hacky logic to make sure we're always the defender. So Todd hit the dragon for 1 damage. Dragon didn't do anything. Todd hit again for 1 damage. So we're doing pretty good. Problem is the dragon has a lot more hit points than we do. But we still are slowly chopping them down. And I think we're getting in trouble. We got 11 HP, he's got 20. We've got 7, he's got 18. So once we get to around 3 HP, I may want to retreat. And I think we just died. But unfortunately, I think the game crashed. I shouldn't say it crashed. What happened is we did get defeated. It returned true. And then the main method executed with that return 0 call. And because we're in debug mode, we're not running that program in a window that stays live. So as soon as the debugger ends, the window closes. So we were defeated. But the logic is pretty good. I'm thinking, I know I need to do some refactoring. And I know I want to add the spell stuff for the mage, the druid spells for the druid, and sort of the backstabby rogueness stuff of the rogue. But I don't want to do that now because I've been streaming for 3.5 hours, which, you know, it's different streaming for 3.5 hours playing a video game than it is actually concentrating on code. So I'm going to take a break. I might not be back though today. I normally only stream Monday through Friday, and the weekends I take off. But I might come back tomorrow. Yeah. Okay, but before I do this, we know our code is working okay. But let's take out my kludge here. Remove the kludge. So now the player has a chance of getting the initiative. Okay. So I'm going to check the code in to GitHub. I just need to open up a command prompt. Let's just make sure Git is on that. Okay, good. So cd c training repo. So repo. So we just called this Tuesday Morning RPG since we started it on Tuesday morning. It's a ripoff of a game on Steam called Saturday Morning RPG, which is kind of like a retro 80s based RPG. Anyway, okay. So let's get add. So we're going to add everything. I'm going to look at the status before I push that though, because I'm pushing up filters, which is okay. Yeah, that's okay. I'm not pushing up binaries or any of that crap. I'm just pushing up our actual implementation file. So that's good. Okay, so we'll commit this. So we'll push this up. So yeah, that's weird, that C out problem. I'm a little bit, anyway. Okay, so I just have to log in. I'll just do that off to the side here. Not that it'll show, I guess, but you never know. I might expose my login stuff. Okay, so it got pushed up. Okay, so now if we go to so if we go to Twitch, there's my homepage on Twitch. Hey, who did I miss? Donnie Priorsburg. Thanks for the follow, Donnie. Rusta Me Behind, I got you. Volatile Majesty, I'm not sure if I gave you the thanks you deserve, but thank you. And QuidJS 1008, I think I got you, but thanks again, guys. Much appreciated. Okay, so now that we're on my Twitch front page, you can just go to the link here to get all of my stuff off GitHub. So here we go. So here's our Tuesday morning RPG I just pushed up, was updated a minute ago. And yeah, it looks good. We've got our SRC folder. So as long as you got Visual Studio installed and the features for C++, then you can build this and do what you want with it. But we'll probably put a couple more hours into it and finish off some of the stuff. I don't want to dwell on it because it was just sort of a game that we just pulled out of thin air. I got other stuff I need to stream anyway. So yeah, so the game is there. Feel free to grab it, fork it, like it, do whatever you want with it. If you think it sucks, don't touch it. I don't, whatever you want to do. It's there if you want. Yeah, okay, I think I'm done. Sorry guys, I am not going to stay around too long. I recommend you follow though, and then at least you get notifications that I'm when I go online. And there might be some stuff you want to learn about. It's all going to be kind of game based somewhat. I'm going to do AI, game AI, where we're going to do pathfinding in C++. I'll probably also do everything else in C# and Java, maybe even JavaScript, maybe even Python. I'm not much of a Python guy, but I should be. So I might even do some Python. But okay, guys, I am out of here. I appreciate you guys watching. That helps a lot. Keeps me motivated. So take her easy, and I'm just about to stop. See you guys.